There are some ideas in science that are so big, so mind-bending, they almost feel like poetry. And the butterfly effect? That's definitely one of them. We've all heard the phrase, but what is it really all about? Well, let's break it down. This is the classic question, isn't it? It's such a dramatic image, this tiny, almost weightless event on one side of the world, somehow causing this massive, destructive storm on the other. But is that for real, or is it just a cool metaphor? That's exactly what we're going to figure out. And hey, as we get ready to untangle all this, if you're the kind of person who loves getting to the bottom of big ideas, do us a huge favor and hit that like, subscribe, and share button. It's honestly the best way to help us keep these explainers coming. Okay, so where in the world did this idea even come from? You might think it's from a sci-fi novel or a movie, but nope. It actually came from a very practical field, weather forecasting. And it's all thanks to one guy. Meet Edward Lorenz. Back in the 1960s, he was a meteorologist over at MIT. And he was using these, for the time, super powerful computers to try and do something really hard: predict the weather. He had absolutely no idea that a little shortcut he took was about to change science forever. And get this, that famous phrase? It comes from the actual title of an academic talk he gave in 1972. You gotta love a scientist with a flair for the dramatic, right? He wasn't being 100% literal, but he was trying to get a huge new idea across. So the key takeaway here isn't that butterflies are tiny tornado-making machines. The real story? It's so much more interesting. All right, let's get to the real heart of what Lorenz was trying to tell us. Because the popular idea, the one we all know, is kind of a misunderstanding of a much, much bigger concept. So the myth is this simple straight line. The butterfly flaps, which causes a little gust of wind, which joins a bigger gust, and so on until you get a tornado. Simple cause and effect. But the reality is way more profound. The butterfly effect isn't really about causation, it's about unpredictability. It tells us that in really complex systems like our atmosphere, the tiniest, most microscopic little change at the start can lead to a completely, wildly different future. And here's the story of how he figured it out. It was 1961. Lorenz is running this long weather simulation. He wants to check his work, so he decides to rerun the last part of it. But to save a little time, instead of typing in the full exact number from his printout, which was 0.506127, he just rounded it to 0.506. I mean, it's a difference of like 1,000th%. It should have made no difference at all, right? Wrong. The new forecast was completely different from the original. That tiny, seemingly insignificant rounding error completely changed the future of his simulated weather. That one shocking result gave birth to a whole new field of science. A field that's all about finding the hidden rules in systems that look totally random and messy. So, welcome to the wild world of chaos theory. Now, I know what you're thinking. The phrase deterministic chaos sounds like a total contradiction. How can something be deterministic, meaning it follows set rules, and chaotic at the same time? Well, deterministic means that if you knew the exact starting conditions, you could predict the future perfectly. But the chaos part means that the system is so sensitive, you can never measure those starting conditions accurately enough to actually make that long-term prediction. And here is Lorenz's own perfect summary. This is the whole idea in a nutshell. Knowing the weather exactly right now lets you predict the future. But knowing the weather almost exactly gives you almost no idea what's going to happen a few weeks down the line. That is chaos. Okay, let's just pause there for a sec. That's the absolute core of the theory. If that just clicked for you, if you just had that little aha moment, let us know. A quick like and subscribe really helps us figure out what's connecting with you. So, if these systems are so unpredictable, does that just mean they're a total random mess? Not even close. In fact, when you start to visualize the data from these chaotic systems, you find something that's not messy at all. You find something beautiful. So have a look here. On the left, you see a system in a nice, stable, totally predictable loop. Boring, right? Now look at the right. This is the exact same system. The only thing that changed was one of the starting numbers by a tiny, tiny fraction. And boom, it suddenly explodes into this incredibly complex, beautiful, chaotic pattern that never, ever repeats itself. But here's where it gets really mind-blowing. If you just let that chaotic system run for a long time and plot every single point it travels through, you get this. This is the famous Lorenz attractor. It's not just random scribbles. It's an infinitely detailed structure. The system is always trapped within this beautiful butterfly shape. It's called a strange attractor, and it's basically the hidden order, the beautiful rulebook, hiding inside all that chaos. All right, this is super cool for mathematicians, I get it. But why should the rest of us care? What does chaos theory actually mean for our everyday lives? Well, it turns out it means a lot. Because this chaotic behavior isn't just in some weird computer model, it is everywhere. Understanding it is obviously crucial for weather forecasting, but also for modeling the stock market, for understanding population dynamics in biology, for building better engines, for creating secure digital codes, and even for training artificial intelligence. It's a fundamental piece of our world. I absolutely love this analogy. Think about it. The flap of the butterfly's wings is like giving an already shuffled deck of cards just one more quick shuffle. You know for a fact that you've changed the outcome. The order is different. But you have absolutely no way of knowing if you just gave yourself a winning hand or a losing one. That's the essence of it. So let's bring it all the way back to our first question. Does the butterfly cause the tornado? The real answer is no. The point is that the butterfly's flap is just one of a practically infinite number of tiny, unmeasurable variables. A tiny puff of wind, a single particle of dust, a slight change in temperature, that all add up to make our atmosphere fundamentally unpredictable past a certain point. And that, in a nutshell, is the butterfly effect. If you feel like you learned something cool today, we'd love it if you'd spread that knowledge by hitting like, subscribing, and maybe sharing this explainer with someone you think would find it interesting. So, we're left with this incredible idea. Chaos theory tells us we live in a universe that follows very strict rules, but at the same time is fundamentally unpredictable. It's not just random chance, but we can't really know what's coming next. So, what do you think that means for how we should plan for the future in our own lives? It's something to think about. Thanks for tuning in.